Hello. It is a huge problem in fundamental physics. The Big Bang theory is coming apart. Quantum theory and relativity are inconsistent. There is a whole zoo of fundamental particles, and we are led to believe that quantum strangeness is just that. We shouldn't really expect to understand the world we live in. There is no such thing as common sense, and things can be alive and dead at the same time. But what if all these difficulties are the consequences of the misinterpretation of that very famous scientific experiment? Surely not. Well, let's have a look at the basics of electricity taught at school. The first thing you learn is that light charges repel each other. And because they do, electric charges on conductors always stay on the outside surfaces. Here is a picture of what we're taught. This is a cross-section through a charged metal conducting sphere. All the charges are on the outside. But hang on, there is a glaring inconsistency here. If all the charges are repelling each other, why are they all crowding close together on the two-dimensional surface? Why aren't they spreading themselves out over the three dimensions of the sphere? In that way, they could get further away from each other, and the charge collection would have a lower energy than the surface-only configuration. Think about when people crowd on a beach. They spread out all over the beach. They make as much room for themselves as possible while sharing with others. They don't crowd together around the outside. So, logically, charges should spread out over the whole volume of the sphere. So why are we taught that charges are on the surface? We need to look at some very important experiments first carried out by the famous scientist Michael Faraday. They are known as Faraday's ice pail experiments. They are experiments looking at where static electricity is to be found in hollow conductors, and so induce the nature of electricity. To keep the video reasonably short, we won't go into the details of the experiments. But the conclusions are that there are two types of electricity, positive and negative. And both positive and negative charges always stay on the outside of the charged conductors. There are no charges ever found on the inside of hollow conductors, because it is impossible to remove charges from their inner surfaces. This neatly accounts for how a Faraday cage works. During lightning storms, it is best to stay indoors or in a car. Then, if you get struck by lightning, all the charges will run over the outside of your shelter to earth, and happily you will not be electrocuted. That is such a natural explanation that it is never questioned. But what if there is another explanation that fits the experimental evidence and allows charges to spread out inside conductors? Let's see how. It involves embracing Benjamin Franklin's view that there is only one type of electricity, and we need to take the charges in pairs, and we also need to recognize that charges never stand still. So here we have an electrically neutral conducting sphere. The pairs of charges shown are delocalized conducting band charges, free to move within the conductor. They are all oscillating, but we are just showing three oscillations. As you can see, the charge pairs move away from each other until they reach the sphere's outer boundary. Here they reflect back towards each other. When they reach their starting positions, their mutual repulsion forces them apart again. Now, it is possible to calculate where these charges are at any point in time. And if you do this for many pairs of charges at many random times, you get this pattern of charges, a snapshot of the system, a quasi-stationary state. Most of the charges are nearer the outside, fewer nearer the centre, and none in the middle. This is exactly what we would expect. The charges are spreading out to give a minimum possible energy for the system, and most of the charges are near the outside. But what has this arrangement of conducting band charges got to do with the ice pail experiments and charged conductors? Well, in a single type of electricity model, a negatively charged conductor simply has more negative charges than a neutral conductor, and a positively charged conductor has less charges. But all the charges oscillate in the same way. Let's hollow out this sphere. As you can see, at the inner boundary, all the oscillating pairs are moving away from the inner surface, so no charges can be removed from the inside surface of the sphere. And this is true for a negatively charged conductor with excess charged pairs, and for positively charged conductors with fewer charged pairs. We deduce that Faraday cages work not because all the charges are on the outside of the sphere, but because charges can't get off the inside of the sphere. There are huge consequences to this interpretation. A rotating charged Earth becomes a viable source of the Earth's magnetic field. Excursions and reversals in the field can be explained by changes of excesses and deficits of charge driven by incoming solar and cosmic events. The non-dipole field can be explained in terms of movements of charge within the dynamic Earth and its atmosphere. Another consequence of this single type of electricity model is that if oscillating charges are investigated at the quantum level and treated as a fundamental electrical process, it is possible to deduce the existence of three-dimensional space. The material world can be explained in terms of process boundaries, and gravity can be explained in terms of charge dynamics. Sentience can be explained in terms of awareness of electrical boundaries, and quantum weirdness disappears. If you're interested in finding out more, please have a look at the other videos on this channel. Thank you for watching. Please like and subscribe, and click the bell to be notified of new videos. Thank you again.